In this chapter, we're going to talk about dependency injection. Before that, let us try to understand the term tight coupling. Let us take a look at some of the real-world examples of tight coupling, thereby you'll understand better. So here from this image, we can say that the pillars and the building are both tightly coupled to each other. That's because, let's say that I found out that the pillars are getting old, and now I have decided to replace all the pillars. I can't replace the pillars alone without disturbing the building. That's because they both are tightly coupled to each other. But the point here is, if I'm making changes to pillars, that will have impact on some other entity. A human hair is another example of tight coupling. You can't pluck the hair from your head without hurting yourself. So plucking the hair from your head will have an impact on your body. Here we have the one last example of tight coupling. The cables of this bridge are tightly coupled to the bridge. If you cut down all the cables, that may cause the bridge to collapse. So what are some good real-world examples of the opposite, loose coupling? Spectacles. You can keep switching the spectacles depending on the color of your choice, and that will not have any impact on your body. So both your body and spectacles are loosely coupled to each other. Removing one from the other will not have any impact on either of the objects. Similarly, a mobile case would be a good example of loose coupling. A mobile case would be loosely coupled with a mobile phone. You can keep changing the skin as you wish. It will not have any impact on the phone. The phone would still function as usual. Now these are all some of the examples of tight coupling and loose coupling in real world. But how about programming? So let us see what is tight coupling in programming. Before that, let us try to understand the term software component. Just as we have a car that is made out of multiple components, for example, a car would have a component called engine, another component called steering wheel, and another component called gearbox, etc. When all these components combine together, we'll have the final product. Similarly, a software product is also a combination of multiple components. Now, these components can be as simple as a simple class, or is combination of set of related files that together will solve a certain problem. I mean, just as with the case of a car, we have a bigger component, which is the engine, which in itself has multiple other components, and we also have some minor components like a steering wheel, for example. And oftentimes these components are dependent on each other in order to function in a certain way. For example, in order for the wheel to rotate fast, you have to press the accelerator. So the component wheel is kind of dependent on the component accelerator. And similarly in software as well, we do have multiple components and are dependent on each other. What we're going to take a look at now is a very simple example of the same. So here we have a very simple example of a component being heavily dependent on another component. We have this Java bean inside which we're trying to instantiate the dog class, and the dog class has just one method in it, which will ask the dog to make noise, and that's the method that we're trying to call from here. Now it's safe to say that Java bean is dependent on the dog class. Only then can it call its method. But we have a very serious problem. Let's say that I've decided to make noise like a cat. Now what should I do? I should go back to my bean and try to make changes in the code. So I'm going to make this a cat and make those changes everywhere. And do take a note that this method is no longer valid. I need to use the method that is specific to cat, which is shout. Now this is a very simple example. Imagine that you're working on a real-world project. You'd have to make these changes in thousands of locations, which is of course not feasible. That's why we need to try our best to make these components as independent as possible, or in other words, We need to make sure that they're loosely coupled to each other, not tightly coupled to each other. So let's continue from next video and see the solution.